today we are doing 7.4, which is going to be quadrilaterals and the coordinate grid. So basically what's going to be happening is you're going to be given a quadrilateral on a coordinate grid, and you're basically going to have to use different things you know how to do on the coordinate grid to figure out what type of quadrilateral it is. So if it's a parallelogram, if it's a rhombus, if it's a square, a rectangle, however you want to say it, we're going to find those properties and we're going to put them into play. Okay, so let's jump into it. All right, guys, so the first thing I want to do is I want to recap on some stuff we know about the coordinate grid. So remember, if you're finding slope, okay, that means if you have the equation y equals mx plus b, the slope is going to be your m. So if I want to find what m is, so m is going to be equal to y2 minus y1 divided by x2 minus x1. Also known as rise over run. That's what we also know that as, okay? So slope of parallel lines, so if I have two parallel lines, I know that their slopes are going to be the same. So for example, if I have y equals 1/2 x plus 2, and if I have y equals 1/2 x minus 4, I know that these two shapes are going to be parallel because their slopes right here are the same exact number. So if their slopes are the same, that means they are parallel, okay? So the next thing I want to talk about is perpendicular. Remember, if slopes of perpendicular lines are going to be known as opposite reciprocals. So remember, opposite reciprocal means you're going to flip and change the sign. So for example, if I have y equals 1/2 x plus 2, if I want to find the perpendicular slope to that, I have to flip it and change the sign. So if I flipped 1/2, that would give me 2 over 1, which is 2 divided by 1, which is 2. And I got to change the sign. So this is positive, so it's going to be negative. So y equals negative 2x plus 2. Right here, if you look, these are going to be opposite reciprocals, which means they're going to be perpendicular lines, okay? Next thing, to find the midpoint. So if I need to find the midpoint of a line, remember midpoint, to find the midpoint, I'm going to do x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. So I'm going to add those together, divide by 2, and that's going to give me my x coordinate. Add the y coordinates together, divide by 2, and that's going to give me my y coordinate. And lastly, the distance formula is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's going to give you the distance of the line. So we're going to be using all of this stuff here to help me to figure out various things about different quadrilaterals to end up qualifying or recognizing exactly what that shape is. So let's jump over to this section, and we're going to name some quadrilaterals that have these following characteristics to help us to find exactly what it is inside that coordinate system. So let's look at it. So let's think back on our last sheet. What are some of the quadrilaterals that have parallel sides? So obviously a parallelogram. We have a rectangle. We have a square. And we have a rhombus. So basically all of those ones that we talked about on the last one have parallel sides to each other, okay? Perpendicular diagonals, meaning when I draw those diagonals, which ones of those are going to make 90 degrees, okay? So I know a square is going to do that. A rhombus is going to do that. And also a kite is going to do that from our old stuff. So we can use that to help us find that. Okay, which ones have congruent sides? So I know a parallelogram. I know a rectangle. No, a rectangle doesn't have congruent sides. Oh yeah, it does, on opposite sides. Yep, rectangle. A square. And also a rhombus has congruent sides as well, okay? Which ones have bisecting diagonals, meaning when those diagonals cross each other, which ones of those are going to bisect each other? So I know a parallelogram does that. Okay, I know a rectangle does that. I know a square does that. And I also know a rhombus does that. Okay? Which ones have perpendicular sides, meaning when the two sides meets, which ones are going to be 90 degrees? And those ones are ones with 90-degree angles. So that's going to be a square, and that's going to be a rectangle, are the only ones that have 90-degree angles at the sides. And lastly, which ones are congruent diagonals, meaning from corner to corner, which ones have diagonals that are congruent? And those are just going to be a square, a rectangle, and also a trapezoid. Now that would be an isosceles trapezoid though, okay? So these are some various things that you guys need to look into whenever we're talking about our examples to try and figure out what exactly the shape we're dealing with. So let's jump over to that example and see what we can play with here. All right, so look at example number 1. It's telling me we need to determine the quadrilateral on the grid by using the properties of the polygon and its diagonals. So we can basically but look at the sides here and we can try and determine if they're parallel, if they're congruent, and that's going to tell me the information I need to prove what type of quadrilateral that this is. So the first thing I'm going to do is I'm actually going to label these. I'm going to label this point A, I'm going to label this point B, I'm going to label this point C and this point D to kind of give me a little bit more of a headway on what I'm supposed to do here. So let's go ahead and see if they are parallel to each other by finding the slopes. Okay, so right now on this right here, I'm going to count over 1 and I'm going to go up 1, 2, 3, 4, 5, 6. So over 1 up 6 means rise over 1 run, so 6 over 1, which means the slope of this line is going to be 6. Okay, so now let's look at the next one. So let's go to B to C. So I'm going to go over 1, 2, 3, 4, 5. And then down 1, 2, 3. So rise over run, so I'm going down 3, so that's going to be -3, and over +5, so it's -3 over 5. So right now, this is going to be -3 over 5. Okay? So now from C to D, I'm going to go over 1 and up 1, 2, 3, 4, 5, 6. So again, that is 6 over 1, which is going to just give me 6. So the slope of that line is 6. And then from A to D, I'm going to go over 1, 2, 3, 4, 5, and down 1, 2, 3, which then again gives me the slope of -3 over 5. So right now, just by looking at these, this is going to be parallel sides on both sides. So now if we look at our notes, the ones with parallel sides are parallelograms, a rectangle, a square, or a rhombus. So that means it's possible that this shape is going to match any of those. So now we need to go further into detail and try and figure out another characteristic to try and go further into it, okay? So now we're gonna look and see, let's look at the perpendicular sides to see if they're perpendicular. Well, I know that opposite reciprocals make perpendicular lines. So if this is gonna be +6 as my slope, that means in order for it to be perpendicular, I gotta flip it and change the sign. So 6 over 1, if I flipped it, would be 1 over 6 and negative. Right now, if you look, this slope right now is not going to be -1 over 6. So that means these two lines are not 90 degrees. So that means I can take out rectangle, I can take out a square because those are not 90-degree angles. So I can take those out. So that leaves a rhombus or a parallelogram. So that means what I need to do, in order for it to be a rhombus, all of my sides have to be congruent. So now I need to check the distance of those. So let's go ahead and do that. So right now, point A is going to be 2, 1. So point A here is going to be 2, 1. Okay. Point B here is going to be 3, 7. So point B over here is going to be 3, 7. Point C over here is going to be 8, 4. And then point D over here is going to be 7, -2. So what I'm going to do is I'm going to take this info, I'm going to plug it into my distance formula, and I'm going to figure out some distance here. So I'm going to do this down here. So right now, let's look at the distance of A to B. So on my distance formula, I'm doing the square root of x2 minus x1. So I'm going to do from A to B. So right now, my formula is going to come out as 3 minus 2 squared plus 7 minus 1 squared. So what I'm going to do is I'm actually going to do my work in here and keep it in radical form unless it comes out to be a perfect square. So 3 minus 2 is 1, 7 minus 1 is 6, 1 times 1 is 1, and 6 times 6 is 36. So 36 plus 1 is going to end up giving you the square root of 37 because 37 isn't a perfect square. So I'm going to leave it in radical form. Okay, so that right there, ladies and gentlemen, is the distance of A to B. So let's look at the distance from B to C. So B to C is going to be 8 minus 3 squared plus 4 minus 7 squared. And then when I work that out, that's going to end up being the square root of 34. Okay, now let's check from C to D. Okay, from C to D is going to be 8 minus 7 squared plus 4 plus 2 squared. And that's going to work out to be the square root of 37. Hey, look, we have a match here so far. And then lastly, I'm going to do A to D, which is going to turn out to be the square root of 7 minus 2 squared plus 4 minus 1 squared. And that's going to turn out to be the square root of 34. So if you look, A to B is 37. A to B is 37. I'm going to do this in a different color. So A to B is 37 and C to D is 37. So that means this line right here and this line right here is congruent. And then it looks like B to C and A to D are 34. So this line right here and this line right here are congruent. So look, opposite sides are parallel and congruent. Opposite sides are parallel and congruent. Not all sides are congruent. So what that means, ladies and gentlemen, is that this shape is just going to be a parallelogram. So we took a shape that was drawn on my coordinate system, we found out characteristics of it, and we were able to prove that this is a parallelogram by comparing their slopes and just comparing their distances, okay? So ladies and gentlemen, we're gonna jump over to example number 2. On example number 2, it says it wants to plot 6,2. 6,2 is right there. It wants me to plot negative 1, 2. It wants me to plot negative 4, 1, 2, 3, 4, negative 5, 1, 2, 3, 4, 5. Okay? And then lastly, it tells me that it wants me to figure out where the point D needs to go in order for it to be a parallelogram. So I know that opposite sides are going to be parallel. So that means for this point to this point and this point to this point has to be parallel. So the slope from this line to this line here, so it's going to be over 1, 2, and then down 1, 2, 3, 4, 5, 6, 7. So from this point, I'm going to go over 1, 2, 1, 2, 3, 4, 5, 6, 7. So boom, right there is where point D would go. Because now if I were to draw my lines here, I know that these two lines are going to be parallel because I just did those slopes. This is a flat line and a flat line, so those are parallel. And now look, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So the distance of those is 7. So right there, since this is parallel and congruent, that means my other two are parallel and congruent, which gives me a parallelogram. So I just compared the slopes and made the new slopes right there to end up making a parallelogram where point D was. Good luck on your skill check and let me know if you have any questions.